Jai Hind students, we'll continue with differentiation. In the previous lecture, we have discussed some formulas for differentiation. There are still some formulas left, isn't it? So let's start with those formulas and then we'll discuss some problems regarding to differentiation, right? So some other formulas are trigonometric formulas for the differentiation of trigonometric functions, right? So differentiation of sin x, it is cos x. Differentiation, it is read as differentiation of sin x with respect to x, that is cos x. Differentiation of cos x with respect to x, it is minus sin x. And as I told you students, this mathematical verification of each and every formula. But being a physics teacher, it's my duty now to concentrate on my subject, isn't it? So the mathematical part, you can solve it in the subject of mathematics. Here, my chief concern is you should be aware of these formulas, and then I will tell you how to apply these formulas in physics, right? So there are some other formulas also, but in physics we'll be making use of these two only, sin and cos. But still, there are some other formulas of differentiation regard to trigonometric functions. So tan x, differentiation of tan x with respect to x, it is secant square x. Then differentiation of cot x with respect to x, it is minus cosecant square x. Fifth, differentiation of secant x with respect to x, it is secant x tan x. And differentiation of cosec x, it is students minus cosec x and cot x. So these are the derivatives of trigonometric functions: sine, cos, tan, cotangent, secant and cosecant, right? And seventh one, differentiation of logarithmic function. So differentiation of log x. I'll talk about natural log. It is 1 by x. And differentiation of e to the power x. E is the exponential. It will remain same. E to the power x only. So these are the 8 formulas, and in physics, first 2 formulas are more than sufficient. So these are the 4 formulas in addition to the formulas which were discussed in the previous lecture. You need to remember these formulas, right? So let's start with some questions based on these formulas. So what we'll do is, suppose we are asked to find out dy by dx when, let's start with 3-4 questions, simple questions. When y is equal to x 3 by 2. Second, y is equal to 7x square. Third, when y is equal to 3x square plus 1 by x square minus 9. Right? And fourth, when y is equal to, suppose it is given to be 9 by x minus 3x cube. Right? So let's start with these 4 questions first. We'll start from the very, very basic. So students, try to recall the formulas which are applicable over here. So let's start with first question. Let's start with the first question, right? Y is equal to x to the power 3 by 2. So what's the master formula? It is differentiation of xn with respect to x. It is n x to the power n minus 1. This is the formula, isn't it? This is the formula. So let's make use of it. First part, y is equal to x to the power 3 by 2. So differentiating both the sides with respect to x. So differentiating both sides with respect to x, we get dy by dx over here, and here it can be written as d by dx of x to the power 3 by 2. Isn't it? Now look, it is in this standard form. So what to do is dy by dx, it would be equal to, compare these two, n over here is 3 by 2 and the formula is nxn minus 1. So what do we get? 3 by 2 x 3 by 2 minus 1. So we'll be left with 3 by 2 x to the power 1 by 2. That is 3 by 2 root x. That's the answer of this first question. Clear, students? Simply make use of this particular formula. Right? Okay. Let's try the second one. Y is equal to 7x square. Which formula is to be used? 7 is constant. We are aware of this formula. D by dx of any constant multiplied by x to the power n. It would be equal to c into differentiation of x to the power n. This is the formula which we have discussed already. So, it's in the standard form of this particular formula. So, let's try to solve it. So, differentiating both the sides with respect to x, what we get is dy by dx is equal to d by dx 7x square. In place of y, right? 7x square. Now look, students, the differentiation of constant is 0, but over here it's constant times x to the power n. So in this case, constant needs to be taken outside the differentiation. So over here, c being constant and over here 7 is constant, it can be taken outside x square. So now make use of this formula, x square, so n is 2. So what's the formula? nx to the power n minus 1. So multiplied by 2x to the power 2 minus 1. So it would be 14x. 2 minus 1 is 1. So the differentiation of 7x square is 14x. Clear? Okay. Let's try the third one. Third one is y is equal to 3x square plus 1 by x square minus 9. So students, here I must recommend initially to start with. This is the beginning of the session and for the first time you are doing this particular topic. So initially take your time, do all these questions step by step. After doing a lot of practice, thereafter you will be in a comfortable position to do these integrations in a single step, right? But to start with, write each and every step, right? Okay. Differentiating both the sides with respect to x, what do you get? dy by dx. In case we differentiate it with respect to time, then we get dy by dt. Here we are supposed to find dy by dx in each of these cases. So what to do is d by dx 3x square plus 1 by x square minus 9. Now all these are functions of x. So it can be divided, d by dx, bracket can be opened up, plus d by dx 1 by x square minus d by dx 9. 9 student is constant. Okay. 3 can be taken outside the differentiation, right? So it can be written as d by dx x square plus d by dx 1 by x square can be written as x to the power minus 2. And students, differentiation of constant, it is constant. So it will be 0. Differentiation of constant is 0. Differentiation is always of a variable with respect to some other variable on which the first variable depends, right? So 3 times differentiation of x square with respect to x. Use this formula, 2x 2 minus 1 plus x to the power n. N over here is minus 2. So the formula is minus 2 x n minus 1 minus 2 minus 1. So that will give us 6x minus 2x to the power minus 3, or it can be written as 6x minus 2 divided by x cube. hope you have understood this. We are simply making use of 2-3 formulas in these questions, right? First is differentiation of x to the power n with respect to x is nx to the power n minus 1. Differentiation of constant is 0. Differentiation of constant multiplied by x to the power n is constant is taken outside, and then differentiation of x to the power n as per this particular formula, right? So we have done the first 3 questions. Let's attempt the fourth one. Let us try to attempt the fourth question. Fourth one is again similar one. We can easily solve it. So it is y is equal to 9 by x minus 3x cube. So let's try to solve it. Fourth one. So differentiating both the sides with respect to x, what do you get? D by dx 9 by x minus 3x cube. Okay. So it is, let's open the bracket, 9 by x minus 3, or we'll do that in the next step, 3x cube, right? Let's keep on solving it and let's see what we get. So 9 is constant, can be taken outside, d by dx, reciprocal of x can be written as x to the power minus 1, right? Over here 3 is constant, it can be taken outside. Over here x cube, right? Again, let's make use of this basic formula. What we get is 9, it's in this standard form, nx to the power n minus 1. Over here n is minus 1, so it will be minus 1 x minus 1 minus 1, n minus 1, nx to the power n minus 1. So nx to the power n minus 1 minus 3. Differentiation of x cube with respect to x. Over here n is 3. So 3x to the power 3 minus 1. So what you get is minus 9x to the power minus 2 minus 9x to the power 2. So it can be written as minus 9 by x square minus 9x square. So students, I hope you are very much confident of using this particular formula, isn't it? It's too simple, right? Let's try some other set of questions. Let's try some other set of questions. Okay. Find dy by dx in these following cases. Y is equal to ax square plus bx, or plus b, let's consider some simple one, to the power half. Second is, let us consider y is equal to, let's say, square root of x cube minus 1. Right? And third one, suppose let's say y is equal to maybe x cube divided by x plus 1. Right? Okay, let's solve these 3 questions. Let's consider the first one. It's a good one. Y is equal to root of ax square plus b. Okay, this is it. So what we do is, let us consider u is equal to ax square plus b. Right? Put this as equation 1. Let us consider u is equal to ax square plus b. Now what we do is, y will become u to the power half. Isn't it? So we can differentiate it with respect to u. We will differentiate it with respect to u. U is a function of x. So here we are differentiating y with respect to u. So what do you get? dy by du is equal to, this should be same. We can differentiate that function which is dependent on another variable, isn't it? So Using the formula, what do you get? Half u to the power half minus 1. That is half u minus half, or 1 by 2 root u, or 1 by 2 u is ax square plus b. Right? Put this as equation 2. This is dy by du. This is dy by du. Also, u is ax square plus b. Here a and b are constants. Here a and b are constants. So, x is variable. So, differentiate u with respect to x. A can be taken outside. Differentiation of x square would be 2x to the power 2 minus 1. Students are writing here directly. Plus, this is constant. Differentiation of constant is 0. So, we will be left with only 2ax. Now look, this is dy by du, this is du by dx. We need to find dy by dx. Right? Now, use simple logic. Dy by dx would be definitely equal to dy by du multiplied by du by dx. Isn't it? Dy by dx is to be found. It can be given by the product of second and third. Dy by du, we are aware of it. It is 1 by 2 square root of 1 by 2 square root of ax square plus b. What about du by dx? It is 2ax. So 2 get cancelled. What do you get? Ax divided by square root of ax square plus b. This is the result. Right? This is the result. Dy by dx is ax divided by square root of ax square plus b. It can be done directly as well. The same quotient can be done directly. This is actually known as the chain rule. So it can be directly done as well. So what we do is, we can get the same answer. So what we do is, differentiating directly with respect to x. So dy by dx, it will be equal to differentiation of ax square plus b to the power half. Right? So what to do is, this can be considered to be a single term. So as per the formula, d by dx x to the power n is equal to nx n minus 1. This is the master formula, isn't it? Make use of this, consider this to be x, the entire term to be x, ax square plus b. So what do you get? nx n minus 1. So n half, x we have considered to be the entire term, ax square plus b, n minus 1, half minus 1, multiplied by the term, entire term, which you have considered to be x, the entire term, the differentiation of that term again. So it will be d by dx of the term which is considered to be x. Over here, ax square plus b. So you can do it directly as well. So what do you get is half ax square plus b, half minus 1 is minus half, right? And differentiation of this term, you can do directly. Open the bracket, a being constant, it can be taken outside the differentiation. Differentiation of x square with respect to x is 2x, so we will be left with 2ax. And differentiation of constant plus differentiation of constant, d is constant, a, b are constant. So differentiation constant b is 0. So we will be left with this. So it can be written as 2 get cancelled. It can be written as ax divided by ax square plus b. Same result can be obtained. So either do by chain rule or you can do it directly as well. Right? So what I mean to say is that if, I'll explain, if u is a function of x, right, and differentiation of u to the power n is given. So how to proceed like? It will be n un minus 1 multiplied by du by dx. Is it okay? We are making use of the same formula. Just now we have discussed it needs to be multiplied because u as a function of x. Clear? Similarly, if you consider this term, differentiation of sine u. We are doing differentiation of sine u with respect to x, not with respect to u. In case differentiation of sine u was considered with respect to u, it would have been simply cos u. But here we'll get cos u multiplied by du by dx. Understood? Similarly, differentiation of cos x. It is minus sin x. So what about cos u? It will be minus sin u into differentiation of du by dx. Clear? So this is the concept which is to be used. So following this, let's try these two questions as well. Let's try to concentrate on question number 2 and question number 3. Let's try to solve it. Question number 2. Y is given to be x cube minus 1 square root of this. Let's do it directly, right? So what to do is dy by dx. The entire term can be considered to be a single one. So d by dx of x cube minus 1 to the power half. Consider this to be a single term. So it will be in the order of x to the power n. So it is nx minus 1. n is half. X, the entire term is considered to be x, which is x cube minus 1. n minus 1, that is half minus 1. Into differentiating that term, which is considered to be x, which is d by dx of x cube minus 1. Directly you can do it. So let's solve it. Half, it will give us x cube minus 1. Half minus 1 is minus half. Differentiation of this term. Differentiation of x cube is, using this formula, we will get 3x square. Minus differentiation of 1. 1 being constant, its differentiation is 0. So we will be left with only 3x square. So it can be written as 3 by 2 x square divided by square root of x cube minus 1. So that is how the differentiation is done. Right? So again I repeat. Basically, if y is equal to xn, then dy by dx is equal to nxn minus 1 into dx by dx. This we don't write. Because it is equal to 1. Isn't it? So this we don't write. So if y is equal to u to the power n, u as a function of x, then dy by dx, it will be equal to n minus 1 into, in place of x, it will be u by dx. Now it's okay. There's not any other formula. The same thing. In case we are differentiating xn with respect to x, then it will be nx n minus 1 dx by dx, which is 1, which is not to be written, right? In case we are differentiating u to the power n with respect to x, then the expression will be nu to the power n minus 1 into du by dx. Similarly, if we consider y is equal to sin x, then what is dy by dx? It is equal to cos x into dx by dx. Again, this need not to be written. It is equal to unity, that is 1. So it is 1. What about y is equal to sin u, and then dy by dx is to be determined. Here u is a function of x. Then the answer would be cos u, and over here du by dx. I hope you have understood the concept. Right? This is how it needs to be done. Let's proceed with some other questions. Okay. Third one. Consider the third question, students. Third one, it can be done by using quotient rule. It's in the form of x cube divided by x plus 1. It's in the form of u by v. Both u and v are the function of x. So what's the quotient rule? d by dx, u by v. As I told you earlier, the formula is denominator square, denominator into differentiation of numerator, minus numerator into differentiation of denominator. This is the formula. This is known as the quotient rule. So let's try to solve it. d by dx, we are supposed to solve this one, x cube divided by x plus 1. So make use of this formula, denominator square, therefore x plus 1 whole square. Denominator multiplied by differentiation of numerator, right? Minus numerator into differentiation of denominator. That's it. I've simply used this particular formula. So what you get is x plus 1. Differentiation of x cube is 3x square. X cube. What is differentiation of x plus 1? Open the bracket, dx by dx is 1. And differentiation of 1 is d1. d by dx of 1 is 0. 1 being constant. So it will be 1 plus 0, that is 1. Divided by x plus 1 whole square. So on opening the bracket, we get 3x cube plus 3x square minus x cube divided by x plus 1 whole square. So 3x cube minus x cube, that will give us 2x cube plus 3x square divided by x plus 1 whole square. This will be the answer, right? So this is the quotient which we have done making use of quotient rule. Okay, let's consider some other examples as well. We can consider, let us consider, suppose y is equal to log x square plus 1. Just now we have discussed. Differentiation log x is 1 by x. So, remember students, differentiation log x is 1 by x. So, differentiation log x square plus 1 would be 1 over x square plus 1. But we have taken this as a whole term, this as a single term x. Into, it will be differentiation of x square plus 1. Right? So, what you get is, its differentiation would be 2x. 1 would be constant, so differential of constant is 0. So, the answer would be 2x divided by x square plus 1. Why? I will tell you what concept I have used. We know that in solving the above question I have used this concept. Differentiation of log x with respect to x is 1 by x. And over here I will write dx by dx. This being equal to 1, it need not to be written, right? So what about differentiation of log u? Over here I consider this to be, it will be equal to 1 by u. It will be equal to 1 by u, that is what I have done over here, 1 by u into differentiation of u with respect to x, into differentiation of u with respect to x. Right? So this is the concept which I have made use of. So these are the questions which can be done directly without using chain rule, isn't it? So for